So we're gonna pick up right where we left off. We got function with two horizontal asymptotes. All right, so we want to find the limits. We're gonna do two of these. So let's go. The limit as x approaches infinity of 3x minus 2 over square root of 2x squared plus 1. We got a little bit yet. All right, so let's flash back to what we did yesterday in the last lesson. All right, so we got to a point we basically went with let's try to divide out by whatever the biggest power is, right? Divide top and bottom. So like here we had x squared in the bottom, so we divided by x squared and so on. We're going to use kind of the same concept here, but the biggest power we have here is x, right? Essentially, on top. All right, so we're going to divide the top by x. Now the bottom, it doesn't really do much for us because it's in a square root, does it? But if I can divide the top by x, I have to divide the same thing by the same factor. Could I divide it by this? The square root of x squared. Not equal to x. The square root undoes a square, correct? It's right there. That'd still just be x to the first power. X is equal to x squared. Okay, so up here, like we did yesterday, we found our highest power. Our highest power is technically just the x on top. Okay, so I'm going to divide top and bottom by that. But if I divide a square root by an x, it does like absolutely nothing for me. So I have to be able to break out the square root, right? But if I'm dividing by x, x is exactly the same as the square root of x squared. So now on the bottom I have a root over a root, and I can make that into a giant square root. That's why I brought in the root of x squared instead of just x. I still divided top and bottom by exactly the same thing. Okay? Is that all right? I just made the one on the bottom a different form, so now I can bring it into the root. Okay? So now on top, we end up with 3x divided by x is just 3 minus 2 over x. On the bottom then, I'm going to have the square root of 2x squared plus 1 over x squared. So now that's going to give me 3 minus 2x on top. On the bottom, I can divide the x squareds out of the first factor. So that's 2 plus 1 over x squared. You guys still with me? All right, now we have 2 of the 4 are now in that form, a number over x to a power, correct? Anytime you have that, the limit of that its exact spot would be 0. So now I have the 3. That's an easy one. 2 over x, that's not equals. 2 over x here will just be minus 0 because it's in that form, number over x to a power. And then the bottom, I'd have the square root of 2 minus 0. Yesterday, we had this rule right here. Anytime in a limit as approaches infinity, if you have a number over x, whether it's the first power or the 10th power, if you just get a number over x, it's always going to have a limit of 0. So in this one here, I have 2 over x. That means I can rewrite it as 0. Bottom, I have 1 over x squared. I can rewrite it as 0. All right, it's just one of our theorems that we were given. So then I end up with 3 over root 2. Now, can I leave it like that? No. Root 2 over 2. 3 root 2 over 2. That would be my limit as x approaches infinity for that function. That's it. All right, now I have it written down here, but if I would do it for negative infinity, if I was approaching negative infinity, all that would change was you basically put a negative out front. Okay, so what do you think it's going to approach then? Negative 3 root 2 over 2. It's the only thing that would change. Okay. Questions? What's that? We didn't get there yet. You'll see here in a second. All right. So limits involving trig functions. These ones are pretty easy. So if I want to look at the limit of as x approaches infinity of sine of x. Now let's think back to what sine of x is. Sine of x is just that sine wave, right? It looks like this. Doesn't it do that forever? Yeah. So it's always going to be between 1 and negative 1, right? But that's a range. Is that a limit? Limit would be an exact value, right? So is there an exact value I can come up with here? No. That does not exist. Okay? Because it's always going to be wavering. Now, if I do this, then x approaches infinity of sine of x over x. Now in this case, what's happening? Well, I still have sine of x on top, so it's still going up and down. It's going to start from 1 to 1. But that x is on the bottom, and it's getting bigger every time, correct? The value of that bottom is getting bigger. So it goes back to that formula we had at the beginning. It's always going to be between negative 1 and 1, but it's going to come out here, and since it's being divided, it's going to start, and it's going to kind of go like this. So what is it approaching? 0, correct? That's because I'm dividing by that factor that I'm plugging in every time. Those ones are pretty simple. You just have to stop and kind of think about them for a second. There's really no calculations. All right, so we're looking at the oxygen level in a pond. All right, so we're going to take a pond essentially, and we're going to say that we're looking at the level of oxygen before any runoff or any pollutants are introduced into the pond. Okay, so we're going to say at f of t equals 1, this would be our normal. Okay, so we're saying this pond is maybe right beside a factory or something, and there's going to be a little bit of waste coming out of the factory. All right, so when it's 1, it's normal. There's already a little bit of pollutants in there. Water's never completely clean. All right, and we're going to say that t is in weeks. So here is the formula, or not the formula, the equation that's going to represent the amount of oxygen in there. T squared minus t plus 1 over t squared plus 1. Okay. So right now at 0, we would have our organic waste, whatever that be before we touch it. So this factory wants to figure out what's going to happen to this pond over time. Is pollution going to go up? Is it going to stay the same? That kind of stuff. So we want to know after 1 week, after 2 weeks, after 10 weeks, and infinitely. Okay. So the first 3, they'd be really simple, wouldn't they? Just plug in the number, right? You don't have to do a derivative, nothing. Just plug in the number. So after 1 week, or where we start at, it's at 50% pollution. All I did was plug a 1 in. So I'd have 1 squared is 1 minus 1 plus 1. So I'd have 1 over 1 squared plus 1 would be 1 over 2. 1 over 2 is 0.5 or 50%. All right with that? Plug in a 2, what happens? I plug in a 2, and I'm going to get 60%. Simple whenever I can just plug a number in. I want to know at a certain week what's the pollution level. And then at week 10, plug it in, I get 90.1%. So it's not looking too good for this pond, is it? All right, but the big thing is, okay, maybe if it levels off at 90%, we can kind of live with it, right? So we want to look at it infinitely. So if we want to look at it over the life of it, now all of a sudden we're changing this into a limit. We see the limit of the function as t approaches infinity. Now, what power of a variable is my biggest power here? No, on the function, squared. So what do you think I want to divide everything by? T squared, right? So I'm going to divide the top by t squared, divide the bottom by t squared. I'm just going to go ahead and split it up. So t squared over t squared minus t over t squared plus 1 over t squared all over t squared over t squared plus 1 over t squared. I just took out the one step where I just wrote it on both. I just divide every term by it. All right, so t squared over t squared is going to be equal to what? 1. T over t squared, well, that would be 1 over t, right? That goes back to a number over my variable. That would turn to 0. And then 1 over t squared, that would also be what? 0. Over, we have the t squared over t squared, so that's 1. And then 1 over t squared plus 0. What's that simplify to? 1, which means 100%. So that factory is basically killing that pond, isn't it? Pretty sure they're not going to be approved for their environmental runoff permits, huh? All right, last couple. Yep, here we got a couple in the back. These are pretty quick. So infinite limits at infinity. So sometimes you do get an infinite limit. All right, remember we talked about this the other day. We ended up with like the infinity over 2 for the 1. We said that a true infinity or a true limit does not exist because it's approaching infinity, which is just a concept. All right, sometimes if you're looking at a certain type, you can get away with using the answer of infinity. Okay, so for instance, this one. If I have the limit as x approaches infinity of x to the third, what would that limit of that be? It goes on forever, doesn't it? Is it approaching a specific number? No. It would be just infinity.
Elena Hamer, please report to the office. Elena Hamer, please report to the office.
All right, and then the same aspect, if I have the limit of x as it approaches negative infinity of the same thing, x to the third, what's it going to do? It's going toward negative infinity, right? So these are just infinite limits at infinity, just kind of talking what it happens to it, what they look like. Same aspect on this one here, 2x squared minus 4x over x plus 1. All right, this one here, if we take it and we divide it by our x squared, we're going to end up with, well, take it, divide everything by our x squared, so 2x squared over x squared minus 4x over x squared, x over x squared plus 1 over x squared. All right. First one's going to be 2, right? Because this is going to go away. Minus, this is going to be 4 over x, which would be 0. Over this one here would be 0. This one here would be 0. Correct? With me? All right, so we get all those. Let me check my work. X squared 2. This would be 4 over x, which is 0. X 1 over x, which is 0. 1 over x squared, which is 0. So what's our limit of this guy? 2 over 0 or 0. Now, here's the problem though. 0 is on the bottom, correct? So would it actually be 0? It's illegal, right? So that would be does not exist. But if it does not exist, what's it really heading towards? Infinity. Okay, so if it doesn't exist, it's essentially heading towards infinity.
Excuse the interruption. Ellen McCartney, please report to the office. Ellen McCartney, please report to the office.
And that's like we talked about yesterday. When it does not exist, that means we did not have an exact value for it. And a non-exact value would be infinity. All right, that would be our limits.